Hello, my name is Jim Mollenauer, and I'm here to talk a bit about standards. I've been involved with standards quite a lot, having chaired the IEEE 802 Committee on Metropolitan Area Networks during most of the 80s and the early 90s. What I want to do is talk a little bit about what standards are all about, why we have them, and why they are a good idea. In a civilization like ours, we find standards for a lot of different things. According to the Wikipedia, the source of all knowledge these days, quote, "A technical standard is an established norm or requirement about technical systems. It is usually a formal document that establishes uniform engineering or technical criteria, methods, processes, and practices." In other words, it's a set of requirements that a designed object has to meet. Now, in standards, there are several types of standards. Standards may be issued by individual companies, by consortiums of companies, or by some official body which is intended and chartered to do standards under an umbrella of international standards and standards groups reporting up to it in most of the developed countries. Why are they a good idea? Well, several reasons. We have in our technical civilization a very large number of things that have to fit together. If A doesn't fit into B, then those two parts can't work together. And this is true for things that are as simple as pieces of wood and as complicated as large computers. As far as wood is concerned, there was an occasion some years back where I was building a partition in my house, and I had some 2x4s around to do it. But it turned out that the normal size of 2x4s, the standard dimension, had changed over the years, and I wound up with about half of each type. And when I finished the wall, it was definitely curving from one place to another, simply because the 2x4s had gone from a finished size of about 3 3/4 inches down to something closer to 3.5. And it showed. So standards can evolve, and the fact that they evolve does create problems that we have to look out for. Another example of standards being useful is shown by the lack of them. When they built railroads in Australia, they wound up using 3 different gauges in 3 different areas. And when the railroads tried to meet, then it was impossible. People had to change trains, freight had to be unloaded, and so on. And later on, during the 20th century, they had to rebuild some of these railroads at considerable expense so that people could travel from one part of Australia to another without too much problem. And in fact, this kind of thing even pertains today on the boundary between Russia and China. Very deliberately, the trains from one side can't run to the other, and all of the cars of the train have to be picked up by a big crane, lifted off their wheels, and dropped onto another set of wheels in order to continue. It slows everything down. It's a big expense, but it's done in the name of security by these countries. In terms of standards for other things, we find sometimes it's the government that promulgates the standard. If you look at the tires on your car, you probably will see a DOT number for Department of Transportation. They have specified standards that govern the safety of tires in order to protect the public. In other cases, there have been standards that have been issued by single companies. For example, the original PCs from IBM made it public just what the standard was for the bus that interfaced between the main processor board and all the peripherals in order to have an open architecture. So many companies started to design not just on the peripheral side, but on the motherboard side as well. And pretty much IBM got a small part of the market. Eventually they dropped out since they couldn't find it profitable anymore. Initially they dropped out of desktop computers and then laptops while still maintaining a good business in mainframes. In other cases, people say, well, standards are not a good thing because they inhibit innovation. Well, the answer to that is yes and no. What standards seem to do is to inhibit minor innovation, but they don't stand in the way of major innovation. For example, in the years after Ethernet came on the marketplace, there were many, many papers presented at conferences, mainly, I think, master's students presenting the work of their master's thesis, all of them proposing improvements in Ethernet. And almost none of them went anywhere. There was one that did, and it almost got voted in. But in the meanwhile, the whole standards area for Ethernet had made a giant step forward in going to a hub-based architecture rather than multiple users along the same cable. And eventually, the proposal that looked like it was going to go through after all was dropped rather late in the game. It really had become irrelevant and superseded by a large step that was represented by the standards. So in all of these cases, we see that the standards have been useful in many respects, but doesn't say that a standard is necessarily going to dominate the marketplace. Some standards simply don't go anywhere. And for example, in the case of IBM, having put out a standard for the personal computer, or PC, they went on to do a different version called MCA for their backplane, for the bus. And that turned out to go nowhere in the marketplace because so many companies had started building according to the first spec that they didn't want to change, and that simply went nowhere. Likewise, a new version of the operating system called OS2 likewise went nowhere in the marketplace. So there's no guarantee that you can do the same thing twice. There's an interesting example in the case of Ethernet, to come back to that in fact initially it was an invention made at the Xerox Research Labs in California. I saw this back in the 70s. It was just a cable running around between computers. But Xerox decided that they ought to bring this out into the world and got together with Digital Equipment, which manufactured computers, and Intel, which manufactured chips. And so these three companies issued what was called Blue Book Ethernet. The Blue Book Ethernet was not an official standard, but it had enough backing that people felt that it was going to be around and last. And so it became popular, and eventually a committee was started up to do an official version of it in an organization that was chartered to do standards. This is IEEE Standard 802. And initially it was expected that they would work on Ethernet, produce an official version of it, and then go home. Well, that was back about 1980, and they're still in business. Getting bigger every year, in fact. And they didn't really do much to change Ethernet. Did some tinkering, but they didn't change it very much. But in the meanwhile, two other proposals came into this committee. And those proposals needed to be heard because one of the principles of standards, official standards process, is that everybody gets to be heard. And it's an open environment where all of the proceedings are public. And the other proposals were one out of IBM called the token passing ring and another called the token passing bus. Eventually these two lost out in the marketplace, but they had a considerable life for perhaps 10 years. But what happened in the IEEE 802 committee was that it was no longer possible to achieve a consensus. Officially, that has to be 75%, so that one can say that there really is a consensus of people in the industry that this particular spec or standard is the right one. And so it was split up into three parts, each of which could independently gather their 75% vote. And so we had 802.3, .4, and .5. .3 was Ethernet, .4 was the token passing bus, and .5 was the token ring. Eventually, Ethernet came up with new innovations, and many improvements in speed, so that by now Ethernet is running in the gigabit speeds, well up from its initial 10 megabits. In fact, originally in Xerox, it was only 3 megabits, but it was upgraded to 10 megabits per second, and over the years it's increased, and new standards have been issued as the technology has improved. And at this point you can find Ethernet being used in many environments where it was never appropriate in the beginning, running over miles and miles of metropolitan areas, point to point. So we find that in all these cases the standards have served to improve the adoption of new technologies. And the reason here is that the standards focus the attention of the manufacturers on a fairly small number of versions, so that economies of scale can be produced. And this is very important in anything having to do with silicon chips. All of the expense seems to be concentrated in the design process. When you build a chip, the first one may cost $10 million. After that, they're $1 a piece. So it really pays to have a situation where there are many chips of the same design produced, essentially printed like newspapers almost, in large chip foundries. And this would not be possible if there were 10 times as many versions of a particular kind of technology. And in fact, in addition to the economies of scale bringing the price down, there's also the interoperability issue. If you have 25 different standards, then the probability that your device can interact properly with another one is pretty small. I discovered this, for example, when videotape recorders first became popular. It was a contest between two unofficial standards, the VHS on the one hand and Sony's Betamax on the other. And it wasn't really clear to me which I should buy with sufficient longevity that I would not have to replace it too soon. So I went down to a video store and I said, "What kind of tapes do you carry?" And they said, "Well, we carry VHS." And so I bought a VHS player, and that turned out to be a wise decision because I really needed something that would play the movie tapes that I could rent from that store and from others. And so this compatibility issue is extremely important in any kind of communications, where we need to communicate from one device to another, perhaps in a different country, perhaps just down the street, but standards that really make it happen. It just doesn't, just not feasible if you don't have those standards. And so it becomes, as our devices become more complex, they become ever more important in the work that we do, in terms of drafting the standards and in terms of using those standards as the blueprint for the devices that we design. So thank you very much, and I hope this provides a useful introduction to the world of standards.